Lecture 11, Persistent Air Presence, High-Altitude Platforms and Balloonships. The week the balloon went down, the sky got crowded. On February 4, 2023, an F-22 fired an AIM-9X Sidewinder and punched a hole through a very large, very slow target drifting off South Carolina. That single shot, and the ones that followed over Alaska, Yukon, and Lake Huron, forced every Air Force and telecom planner to revisit a neglected layer of the battle space, the stratosphere. The band above jets and below orbit, ugly and useful, where persistence beats speed. The fights since have been quiet ones, over spectrum tables, procurement lines, and radar filters, but the platforms are real, the flight hours are logged, and the doctrine is catching up. According to congressional records and public summaries, the 2023 Chinese high-altitude air object was downed by a Sidewinder after days of continental overflight, and lawmakers labeled it a sovereignty violation. More importantly, North America's air defense enterprise began adjusting sensors and tactics to stop treating slow and high as ignorable clutter. While the headlines cooled, industry did not. Airbus spun its stratospheric program into Alto HAPS, pulled investment from Japan's NTT Docomo and Space Compass, and kept tuning Zephyr, the solar aircraft that lives where weather thins out and horizons stretch. Company materials now advertise live video and 18-centimeter imagery from the stratosphere, with typical daily coverage in the low thousands of square kilometers. The same pages show the pivot to commercial services in 2026 backed by that Japanese stake. In other words, this pseudo-satellite layer is not a PowerPoint wish. It is being capitalized, scheduled, and productized. The Navy, not to be outdone, has taken a liking to solar persistence at lower, friendlier altitudes. In late July 2025, Naval Air Systems Command reported a non-stop 3-day flight demonstration with Skydweller Aero, the carbon fiber Leviathan reborn from solar impulse and now aiming for months aloft. Skydweller's own notes in early August 2025 used the phrase, perpetual flight. You can taste the ambition in that word, eliminate the landing. For maritime surveillance and signals intelligence, an uncrewed airplane that can loiter over oceanic gaps for 90 days rewires tasking math and tanker math alike. Balloons, which never needed to apologize for being slow, have quietly swallowed the record books. Aerostar's Thunderhead superpressure craft stayed in the stratosphere for 336 days, nearly a year, ending on March 24, 2025. The company had already passed 200 days with another vehicle in 2024. Persistence used to mean weeks, or a tour, now it means seasons. The word, controllable, in those releases matters, because modern long-duration balloons steer with altitude, riding winds like stacked rivers, not thrashing against them like boats with bad motors. That is how you carve station keeping from moving air. Airships are the middle child here, bulkier, with real payload volume and more honest station keeping. Psy, working out of New Mexico, has completed day-night cycles in the stratosphere and is working with NASA and the U.S. Geological Survey on methane detection, civil work with obvious military echoes in wide-area emissions mapping. Airship endurance is currently measured in days, not months, but the runway is clear. Rigid structure means more aperture area, more batteries, more power budget to push heavier sensors and robust radios. Persistent air presence is not one thing. It is a stacked ecosystem across altitudes. At the high end, high-altitude platform stations, say the acronym once, HAPS, live between roughly 18,000 meters and 24,000 meters, cruising above most weather. Fixed-wing HAPS like Zephyr trade speed for endurance, using photovoltaic arrays to charge battery packs in daylight and then glide carefully through the night. Airships occupy similar altitudes with better station keeping and more payload, at the cost of drag and delicacy. Superpressure balloons maximize endurance and altitude but give up instantaneous control authority for low-energy navigation, using vertical migration to grab a wind layer that pushes them the direction they want to go. The physics are blunt and useful. At 20,000 meters, the radio horizon to a ground receiver is on the order of 500 kilometers, which makes a single platform an obnoxiously well-placed tower for cellular coverage, data relay, or passive radio mapping. According to Airbus, its StratObserver payload is delivering live video and imagery from the stratosphere with roughly 18-centimeter detail, consolidating some satellite and drone tasks into a single high perch for days or weeks. And Japan's telecom sector is not waiting. The 2024 investment is expressly about commercial launch in 2026. Spectrum and regulation are not glamorous, but they decide who gets to speak. The International Telecommunication Union's World Radio Communication Conference in 2023 identified additional bands for HAPS base stations, an unsexy sentence that meant, you can stand up networks from the sky without stepping on your neighbor. Operators built momentum with demonstrations, stratospheric platforms, and Deutsche Telekom started flying their airborne mast concept, integrating a multimeter phased array into a workhorse turboprop to validate beamforming and handoff. And this spring, Space Compass and NTT Docomo linked 4G smartphones from a HAPS at 20,000 meters above Kenya. These are not toys. They are towers you can move. The Chinese balloon affair taught everyone two operational lessons. First, slow and high can be hard to categorize in air defense stacks tuned to find fast and low. Radar filters built to ignore birds and weather will also ignore balloons. Remove the filters and you suddenly discover a sky full of things you never meant to look at. North American radar modes were adjusted after February 2023 to see smaller, slower targets. The result was more interceptions and a dawning awareness that there is always traffic aloft. Second, shooting down gas and fabric is surprisingly non-trivial. A sidewinder missed over Lake Huron before the second one connected, a reminder that missiles are engineered for aircraft that glow hot and maneuver, not cold sailcloth drifting at odd speeds. Each AIM-9X costs mid-six figures. Used as a balloon shredder, it is both effective and fiscally noisy. Let's take the covers off the systems. Start with sensors. The HAPS camera suite you will actually see in the next 5 years is not a giant telescopic fantasy. It is a cluster of light, steerable electro-optical cameras paired with stabilized gimbals, good glass, and onboard image processing that handles compression and change detection at the edge. Airbus advertises very high resolution, down to roughly 18 centimeters, from the stratosphere and talks openly about streaming live video. Infrared channels matter for night and for smoke. On the balloon and airship side, payload mass is the limiting factor. You can fly a small synthetic aperture radar, say it once, SAR, or a compact electronic intelligence package for emitter mapping, but everything is countable in kilograms, watts, and heat rejection. The Zephyr data sheets have long listed radar and LiDAR as options, but the programs going operational first are optical and radio. Computation rides shotgun. The autonomy stack is boring in the right ways, energy management keeping battery state of charge above a minimum through the night, thermal limits that throttle processing or cameras when the air is thin and cooling is a privilege. Flight control law biased for minimal turns and elevator movements to save watts, path planners that treat winds as conveyor belts instead of headwinds to be beaten. Edge compute on these birds is not a data center, but it is sufficient for motion detection, target cue extraction, and ultra-low bitrate change messages that tell a human or a shooter what matters. Power budgets set the ceiling. Zephyr has flown with lightweight batteries near 435 watt-hours per kilogram, a 24 kilogram packet that specific energy yields on the order of 10 kilowatt-hours to trade through the night, and you can feel the tightness of the math in winter latitudes and short days. Communications is the bloodstream. Line of sight from 20,000 meters means you can stand up a burst relay over a region the size of a small country. The telecom story is blunt: if you can hang a base station in the sky, you can bridge valleys and islands without digging or permits, then move it next week. Operators have demonstrated LTE and fifth-generation links from airborne masts tied into real networks. The ITU's post-2023 allocations removed much of the regulatory hardpan. Militaries get the same advantages with better radios, wideband downlinks to ground stations and ships, crosslinks between aircraft, and the option, soon, to use optical links between platforms. The German Aerospace Center and partners have been pushing 10 gigabit per second laser links for HAPS to HAPS networking, and if that sounds like a lab trick today, remember the last decade of free space laser comms. Physics is on your side when there are no clouds. Weapons on a platform built to sip sunlight are a provocation to the power budget. You will not see a directed energy cannon on a Zephyr variant. A high-energy laser wants tens to hundreds of kilowatts and kilograms of thermal management that a glider cannot afford. The directed energy that matters in this layer in the near term is optical, for comms and for sensor dazzling, not for burn-through. Where lethality shows up on HAPS is in kill chain plumbing, not nose guns. The platform finds something else kills. Practically, that means a HAPS or balloon cues a surface-to-air missile battery, or a long-range rocket artillery unit, or a shipborne vertical launcher. It sends stabilized coordinates, a track file, and updates. If you want a flying platform that both sees far and carries steel, you step down in altitude and up in payload to the Skydweller class. Fails and Skydweller talk openly about hundreds of kilograms of payload, enough for a maritime radar, an electro-optical turret, and a rack of expendables. You could, in extremis, mount a couple of light glide munitions and still have endurance in the weeks bracket. That is not science fiction, it is weight accounting. Balloonships use the word because it captures the new breed of superpressure vehicles with avionics and mission systems, don't throw punches as much as they hold the enemy down for someone else. They are excellent at persistent stare and passive collection. They are also becoming excellent at being cheap, which is a weapon in itself. Aerostar's long-duration flights show what the materials and navigation now allow, hundreds of days aloft with controllability. NASA's structural work on superpressure envelopes reads like an ultralight manifesto, polyethylene films down around 38 micrometers thick, reinforcement tendons that carry the stress, pumpkin geometries that hold shape through day-night buoyancy swings. It is industrial sorcery. How it actually operates is where the romance dies and the winds begin. A HAPS mission commander wakes to wind charts. The software proposes energy-feasible loiter patterns that keep solar incidence high in the day and lift expenditures low at night, with alternate altitudes for crosswinds to reposition. The autonomy stack respects three constraints that never change: power, thermal, and comms margin. If a midday cloud deck kills charge rate for an hour, the computer sheds payload power, tilts for max solar capture, and adjusts the night profile. Targeting is not fire control so much as find and feed. The payload flies a lawnmower pattern across a box, detects motion or a spectrum feature, and composes a message to the network: coordinates, grid confidence, a thumbnail, then a human picks the needle from a very small haystack. Human on the loop, not in it, until a weapon is pointed. That boundary is both ethical and practical. The system can watch on its own, but the decision to shoot stays anchored to an operator. That constraint is not decorative. It is regulatory reality inside many militaries, and a safety valve for escalation in a domain where sovereignty laws consider a balloon an aircraft, not a neutral weather angel. Weapon effects still matter even when the platform does not carry the warhead. The geometry from 20,000 meters favors long-range surface-to-air and surface-to-surface weapons that can use third-party targeting. A cruise missile flying at 50 meters above the sea line is hard for a ground battery behind clutter to see. It is easy for a stratospheric camera looking down sun at the wake pattern. A ballistic missile lofting toward a theater target is a thermal spike with a bright tail. A balloon-borne infrared sensor can cue long-range interceptors much earlier than a ground radar blocked by geography. When those interceptors arrive, the warheads are what they always were. Fragmentation rings cutting airplanes with metal rain, hit-to-kill bodies turning closing speed into pulverized kinetic energy, radar fuses threading bursts across cruise missile bodies. There is no euphemism here. The persistent layer detects, tracks, and hands off. The shooters shatter things. Why this wins in operations is obvious to anyone who has tried to keep a satellite tasked, a tanker scheduled, and a human crew awake. Persistence annihilates friction. A balloon or HAPS can loiter above a border for a month, stream a stitched panorama every 5 minutes at workable resolution, and do it without diplomatic overflight clearances or orbital mechanics telling you to wait 90 minutes for the next pass. A solar aircraft can trace a sea lane for days without a single pump of JP-8. If your opponent has to spend an AIM-9X, or worse, an AMRAAM, or roll a medium-range surface-to-air missile to kill a plastic envelope or a carbon spar, the exchange rate is punishing. When Ukraine began using balloon drones to drop mortar rounds on Russian infrastructure in 2024, nobody pretended they were precise or elegant. They were persistent, hard to find, and cheap enough to throw away. The kill chain economics of near-space platform versus high-end interceptor are not kind to the defender. The glide path from 2025 to 2035 is practical, not miraculous. Expect 3 milestones. First, telecom-grade service from HAPS goes live in places where fiber trenching is a cruel joke: archipelagos, mountains, deserts. Japan's money is on the table for 2026, and European carriers are prodding vendors to price services like real towers. Second, air defense networks learn to treat the stratosphere as a combat domain. Canada's NORAD modernization work on over-the-horizon radar is the big block here: wider coverage and better track custody of slow movers. Exercises in the Pacific have already used high-altitude balloons with electromagnetic sensing and mesh relays. That experimentation becomes monthly business. Third, airships find a durable niche as methane mappers, maritime pickets, and national border sentinels. Each of those is a dual-use job that funds the rest. Geopolitics and industry will push and pull the pacing. Helium is becoming a strategic resource again. Analysts in 2024 warned that demand could nearly double by 2035 off the back of semiconductors and other high-tech sectors. Prices rose through 2025 and volatility has not been kind to anyone inflating anything. That alone nudges programs toward hydrogen lift in test events and toward thin film efficiency and reuse. Meanwhile, the legal and regulatory screws are turning. Legislation in Washington has pushed the Federal Aviation Administration to propose continuous tracking standards for high-altitude balloons. And international bodies are wrestling with the same question they have dodged for decades: where air ends and space begins. None of that stops operations. It does shape what transponder you weld on. Counter-systems are already in play. Electronic warfare is the first, cheapest answer: jam the downlink, spoof the navigation, blind the camera with ground-based lasers when the sun is right. Then come the kinetic answers. Guns are useless at those altitudes. Even most surface-to-air missiles are not happy chasing fabric at stratospheric heights and odd closure rates, though they can do it with the right seekers and shot doctrine. Fighters can take the shot, but the cost exchange rate is ugly and misses happen. Directed energy on the ground is a better long-term bet. Dazzle or burn through under clear skies at long slant ranges, an approach that navies are already proving out against drones at sea. And then there is deception, decoy balloons, false radar reflectors, and a sky salted with cheap targets to waste missiles and time. The decoy race in Ukraine, fake radars, mock missiles, sacrificial drones, has already forced both sides to spend real money on fake things. Expect the same overhead. Resilience and sustainment look boring until you do the math. The energy math is stark. At noon in the tropics, you might see roughly 1 kilowatt per square meter of solar irradiance. With high-efficiency gallium arsenide cells, you harvest a fraction of that. Realistic platform numbers translate to kilowatts in daylight and a battery that carries you through 10 to 12 dark hours with tight reserves. That is why latitude bands matter for Zephyr-class aircraft and why winter high latitude remains a red zone for solar persistence. The attrition math is more forgiving. Balloons can be launched by the dozen from a parking lot, envelopes are measured in thousands of dollars not millions, and reconstitution timelines are days, not months. Airships are slower to build and recover but bring payloads that justify the patience. The budget math is the punchline. If the defender is spending hundreds of thousands of dollars per shot to swap platforms that cost a rounding error, you do not need to win every exchange to win the war of accounts. Law, norms, escalation, these count when balloons cross borders. Under the Chicago Convention as interpreted in U.S. Indo-Pacific Command guidance, high-altitude balloons are aircraft, not satellites. They are subject to national airspace sovereignty regardless of altitude. There is still no treaty line between air and space, no agreed-upon common border that flips legal regimes. That ambiguity is tolerable in peacetime until a slow mover drifts over a nuclear site. The safe operational norm that is emerging is simple: if you are not invited, you are target, and your launch authority should plan for your asset to be either escorted or killed. Humans still matter in this loop for 3 reasons. First, judgment about what to watch is not a solved problem. Change detection will tell you something moved. Only a human looking across a whole campaign will feel which something matters. Second, escalation control is not a checklist. When you see a balloon over your allies harbored during an exercise, the decision to shoot it down or shadow it is political and strategic, and you want a person owning that. Third, creativity lives with crews. The best teams are the ones who think to turn a HAPS over a wildfire line into a multi-agency cellular lifeline, or who use a balloon as a passive listening post to map an adversary's jammer by its own spillover. Machines do the labor. People pick the fight. Which means you design the network to let humans choose the moments that matter. Navigation first. A balloon ship steers without wings by changing height, riding stacked wind lanes like moving sidewalks layered one above the other. The rule is simple: climb if the wind at 22 kilometers is drifting west and you need west, sink if the stream at 19 kilometers is sliding east and you need east. Aerostar's Thunderhead makes that abstraction real by trimming altitude with gas management and ballast, then holding a slow racetrack over an area of interest for weeks to months. The company's own material is explicit about leveraging directional wind patterns at high altitudes to persist where you want, not where the wind wants you to go. In March 2025, Aerostar closed a 336-day flight of a controllable Thunderhead, the longest continuous stratospheric flight by any steerable vehicle to date, proving the winds can be tacked like a sailor tacks a breeze if your envelope, valves, and autonomy are good enough. Fixed-wing stratospheric aircraft solve the same problem a different way: wings and very patient airspeed. Airbus's Zephyr, now operated by Airbus spin-off AALTO, climbs to roughly 20 to 23 kilometers, then walks its loiter box with slow, continuous thrust and very high aspect ratio wings, sipping solar power by day and running batteries at night. After a 64-day run ended in Arizona in 2022, AALTO pushed past that mark with a 67-day, 6-hour, 52-minute stratospheric sortie that ended on April 28, 2025, a new continuous flight record for any aircraft. The company and independent trade press both put hard numbers to it, and Amprius, the battery supplier, touted the achievement as a validation of its high-specific energy silicon anode cells. The flight launched from Kenya, ran connectivity tests, and transited multiple flight information regions before a controlled termination in the Indian Ocean, underscoring that this is now a system that can do multi-week missions at will, not a laboratory curiosity. Sensors are the reason to be there, so be concrete. From 20 kilometers, the angle and the air are kind. Airbus's StratObserver package on Zephyr and Balloon platforms is spec'd for live video and stills down to 18 cm ground sample distance. That is not a euphemism. 18 centimeters means you resolve the individual bricks in a wall, the gaps in revetments, the type of wheel on a short bed truck. Airbus's public technical pages advertise daily coverage on the order of thousands of square kilometers with steerable fields of view, and targetable sub-kilometer imagery at that resolution. In other words, a single persistent eye that can stare and then immediately glance. Communications do not need to be hypothetical either. Deutsche Telekom and Stratospheric Platforms demonstrated stratospheric LTE integrated into a live network in 2020. In March 2025, Space Compass and NTT Docomo announced tests over Laikipia County, Kenya, linking ordinary smartphones to a HAPS at around 20 kilometers, exactly the use case the International Telecommunication Union endorsed at the World Radio Communication Conference in 2023 when it recognized high-altitude platforms acting as cellular base stations as part of terrestrial mobile networks. And the optical backhaul is not science fiction. German Aerospace Center presentations summarize bidirectional air-to-ground laser links at 10 gigabits per second and inter-HAPS laser networking concepts at similar rates. At altitude, you can build a mesh above the weather and hand multi-gigabit streams down only where you need them. Power is the whole game for aircraft that never land. Specific energy is the number to watch. Amprius and its peers are not shy about publishing it, over 435 watt-hours per kilogram in silicon anode lithium-ion cells, with platforms now fielding variants at 500 watt-hours per kilogram. That is why Zephyr's night legs keep getting longer. It is why Faza, 35, BAE's British HAPS, can run 24 hours in the stratosphere and land in flyable condition 2 days later, ready for a quick turn. Battery mass that once paid for 6 hours now pays for 9, then 12. The physics do not bend for anyone, but chemistry and aerostructures are stealing back margins year by year. Balloonships are the payload capacity and station-keeping monsters of this ecosystem. Size Airship is a helium-filled, solar-augmented platform designed explicitly to hold position day and night. In August 2024 the company completed a full diurnal stratospheric flight, day and night on solar and stored energy, while staying over its area of operations. A month later, NASA's Earth Science Technology Office documented a 24-hour stratospheric test of an interferometric synthetic aperture radar on a side platform at 55,000 feet, the kind of wide-area deformation and change sensing that matters for pipelines, ports, and runways. And by late 2024 SI had a cooperative research agreement with NASA and the U.S. Geological Survey on methane superemitters and hazard monitoring. That is what persistent air presence means when the mission lasts longer than a weather system. Now fold it into the kill chain and be literal. A stratospheric picket with an 18-centimeter optical head and a radio cross-queue to a maritime patrol aircraft will see a fast attack craft depart a cove in Sea State 3, hold it across a shoreline where ground clutter defeats shore-based radar, and keep it through the turn that brings it into coastal shipping lanes. The handoff to a missile unit is not a hand-waving effect, it is a set of coordinates with update rates you choose. If the target outruns your crosswind, you climb into a different wind lane and steal a few knots of drift in your favor. If it hides behind smoke, you pivot to radar from orbit or to ground receivers that catch its own emissions. The point is tempo without a satellite tasking queue. The same physics makes air defense both easier and harder. It is easier because persistent angles generate better tracks, No more trying to reconstruct a threat from 3 strobe lights that blinked once. It is harder because the other team does not need to spend much to force you to spend a lot. In February 2023, a Sidewinder shot at a slow high-altitude object over Lake Huron missed on the first try, the second connected. The miss was not a scandal, it was a lesson in seeker logic and edge cases, and it came the same week North American Aerospace Defense Command admitted it had retuned its radar filters to see slower, smaller things after the first Chinese balloon was detected. The defense problem is now a long tail of weird stuff. Which is why decoys, jamming, and deception are already baked into the air above the stratospheric shelf. Russia has lofted cheap balloons carrying radar reflectors, a way to bait Ukrainian air defenses into lighting up or shooting at phantoms, and reporting from the war has chronicled mass use of decoy drones alongside real ones. Ukraine responded in kind, experimenting with long-range balloons that carry mortar bombs and with balloon-borne electronic support gear to sniff out enemy drone operators. None of that is glamorous. All of it is operationally rational when a decoy costs hundreds and a missile costs hundreds of thousands or more. Law and Spectrum choose the edges of the box. In 2023, the International Telecommunication Union's World Radio Communication Conference formally recognized high-altitude platform stations acting as cellular base stations as part of terrestrial mobile networks, clearing a cleaner regulatory path for service in licensed mobile bands. In the United States, Congress wrote tracking mandates for high-altitude balloons into the 2024 Federal Aviation Administration reauthorization. The agency's own summary of Section 361 is explicit about continuous tracking of altitude, identity, and location. Those two steps pull in opposite directions. One removes friction for commercial HAPS networks, the other raises accountability in the wake of real incidents. Both were overdue. Keep the counters honest. Directed energy air defense is not a panacea, but it is not a myth either. The U.S. Navy's Helios laser on USS Preble shot down an aerial target in testing reported for fiscal year 2024. The Navy published multiple official releases about earlier shipboard laser shots with the USS Portland demonstrator, and independent reporting in 2025 pointed to the first Helios engagement of a drone target. Israel's Iron Beam program has telegraphed operational ambitions for 2025. None of these erase air defense's vulnerability to saturation, as the June 2025 Iranian volley demonstrated in practice. What the lasers do is change the cost curve when the weather cooperates. A Balloonships camera does not need to kill anything. It only needs to spot for a laser that shoots for a handful of dollars per round. The autonomy stack is boring because it has to be. It is a layered supervisor, not a hotshot pilot. Health management watches the envelope, the gas, the battery, the motors. Guidance watches the wind field and the mission box. Navigation is fused GPS, start tracker when you can, inertial dead reckon when you must. Communications rides whichever link is fat and legal, Ka-band SATCOM. When you are over the ocean, optical downlink when you are over clear air, S-band backhaul when you are over contested electromagnetics. The human on the loop decides policy questions, how close to a border you are willing to loiter, which target merits a priority track, when to hand a sensor to a shooter. That is the right division of labor for platforms that do not land this month. If you want to know why stratospheric persistence wins, do the sustainment math in plain language. A fixed-wing HAPS carries a handful of kilograms of mission payload with a few dozen kilograms of batteries and structure. If your batteries really are at around 500 watt-hours per kilogram and your night draw is roughly half a kilowatt for 10 hours, you are spending about 5 kilowatt-hours of stored energy each night. 10 kilograms of battery buys you that overnight leg with some margin. Add a second 10 kilograms to manage poor Sundays. It is inelegant arithmetic, but it scales. Balloonships scale differently. Their buoyant volume, film, tendons, and solar blanket push you into payloads measured in tens to hundreds of kilograms. They do not pay a drag penalty to stay up, the way wings do. They pay in helium and envelope fidelity. The decisive number is not the one on a glossy brochure. It is how many nights you can survive when 2 sunsets in a row are ugly. Supply chains make or break that survivability. Helium is not made by engineers, it is mined with natural gas and sits inside geopolitics. The U.S. Geological Survey's 2025 Mineral Commodity Summaries notes global helium production rose about 4% from 2023 to 2024, but that is against a demand curve many forecasters expect to climb steeply. IDTechX has projected demand nearly doubling by 2035, with semiconductors the villain you cannot fire because everything else you want to do, AI, quantum, lasers, rides on that same supply chain. Translation: your balloon fleet has to get stingier with helium or leak less of it, otherwise you are building operational risk into your gas budget. This is exactly why you see so much interest in airships that launch with helium but never vent, and balloons with better film gas tightness and valve discipline. Reliability is now an operational variable, not a press release. Zephyr's 2022 loss after 64 days was a useful public lesson in high-altitude turbulence and the perverse risks of descending through weather after months above it. The point is not that fixed-wing HAPS are fragile, the point is that you design your aborts with the same care as your crews, sanctuary splash zones, energy margins to wave off, and a telemetry stack that tells you days in advance that your packs are decaying or your film is creeping. The Royal Aeronautical Society's post-loss write-ups and engineering press coverage were candid on this. Fixing the control laws and energy margins is the whole reason 2025 looked different. Weapons encounters keep each other honest. Lasers at sea are maturing, with the US Navy's Helios on USS Preble burning an aerial target in fiscal 2024 and the older Portland laser demonstrator disabling a drone in 2020 and torching a surface target in 2021. That matters. Because once you can reliably put tens of kilowatts on a fragile wing or a balloon's tendon field, your cost curve for kills bends toward the ship with the generator. But it cuts both ways. The Balloonship constellation that costs you tens of thousands per node can trade attrition with $1 million interceptor all day and still win on exchange ratio. The practical answer is redundancy and maneuver. Platforms move. Constellations cross-cover. And anything that cannot maneuver carries decoys and a Grim Reaper app that tells operators to terminate before a capture. Balloon warfare has already gone low-rent and lethal in Ukraine. Public reporting documented helium balloon, bomber, drones dropping mortar rounds guided by cheap autopilots, and both sides have used balloons as decoys and as radio relays to stretch the range of ground drones. It is a reminder that in the stratosphere you buy exquisite persistence, but in the layer cake below it physics is cheap. A bag of gas, a GPS, and gravity will ruin someone's day if you do not control your airspace. The difference at 20 kilometers is governance, the difference at 2 kilometers is whether you can see and jam. If you are building the ops center around all this by 2035, your dashboard is simple. Energy state for each platform. Link health, optical backhaul and downlink spectrum occupancy. Weather field above and below. A geofence library tied to rules of engagement and airspace authorities. And a row of promote to shooter buttons that the human can touch only after an AI stack has done the rote work, correlating synthetic aperture radar change detection with electro-optical tracks, checking electronic emissions against known order of battle, and marking everything that smells like a decoy. People watch the edge cases, not the clutter. By 2050, you assume lasers, high-power microwaves, and rail-thin interceptors are all part of the air defense web. The best platforms, solar fixed-wing for wide-body persistence, airships for payload, balloons for numbers, carry their own soft kill, dazzlers, interference shaping on the downlink, and spoofer-aware positioning that makes a jammer burn itself alive. You also assume that recovery and reconstitution are routine. Aerostar's cadence hints at it already. The day you can launch a dozen steerable balloons before lunch and recover 2 the evening to swap payloads, you have turned persistence into a logistics drill rather than a hero project. And yes, the maps change when you stitch all of this into continental defense. Canada's Arctic over the horizon radar grid, the 4 sites, 2 transmit and 2 receive, targeted for initial capability by 2029, extends the warning line, HAPS fill the view gaps, soak the Arctic shipping lanes, and provide jamming-resilient relay paths that do not depend on a single satellite bus. Once you can drape laser and microwave trunks from HAPS to ground fiber, your everywhere radio becomes a thing, even where towers make no sense. That is what persistent air presence actually buys you, a geography-agnostic network and a stare that does not blink when the weather turns ugly. We should not be romantic about sustainment. Helium stays tight only if your films and valves are good. Batteries live long only if your thermal control is better than your pride, and solar aircraft only work if your operational latitudes and seasons are matched to their power budget. But the trend lines are clear. Optical backhaul at 10 gigabits per second is not exotic. A single HAPS payload can collect 18-centimeter imagery over thousands of square kilometers per day, with steerability that turns revisit into you have live video now. And carriers are placing their bets, not just with press releases but with flight tests to handsets and 8-figure equity checks. The stratosphere has finally become a layer we can occupy, not just cross. Now imagine the human side, because the friction sits there. You train operators who think like network engineers as much as pilots. You write your standard operating procedures to assume you will be blamed for anything that drifts, and you log every second of telemetry so that when a national aviation authority calls, you can produce altitude, location, and identity without breaking stride. And you keep repeating the same principle until it is muscle memory. People choose, machines chase. The platform's job is not to be clever. It is to be present, to be cheap enough to be fearless, and to hand a human a clean, timely choice. Which is why the next edge to sharpen is signature management. The lie you tell the sky is simple, be boring. A balloon ship is a cold sack at ambient, reflective film turned to the sun, payloads buried behind low scatter windows, emissions prone to whisper salvos. A fixed-wing HAPS keeps its props slow and its fuselage smooth, then lets geometry do the rest. From the ground, slant range and a sparse thermal plume beat most short-range infrared trackers. From the air, a fighter's radar sees only a small, slow cross-section that moves like weather. The counters are obvious and already in motion. According to Reuters reporting the week after the 2023 Chinese balloon shoot-down, North American Aerospace Defense Command retuned its filters to stop discarding slow movers and opened the gates, which is the radar operator's way of saying, we chose to see the clutter and sort it in software. That is the correct response in a world where persistence at altitude matters as much as speed at low level. Cost exchange is the next uncomfortable truth. If you force a defender to shoot a $1 million class interceptor at a sack of helium and plastic that cost a rounding error, you do not need exquisite effects to win the ledger. The Missile Defense Advocacy Alliance's running totals put an AIM-9X Sidewinder near the $1 million mark in National Advanced Surface-to-Air Missile System use. Contemporary reporting on the Air Force's AMRAAM buys puts those missiles in the million-plus tier as well. The point is not the exact invoice. It is the shape of the curve. The platform that soaks attention and draws expensive fire has already done violence to a defender's magazine depth and budget line, and the second-order effects, tankers, alert fighters, radar hours, compound the pain. Connectivity is the bloodstream and the bottleneck, so the smart teams are building two independent trunks, radio to the user, optics for the backbone. Deutsche Telekom and Stratospheric Platforms, Limited, demonstrated stratospheric 4G integrated into a live network back in 2020. By March 2025, Space Compass and NTT Docomo were linking ordinary 4G handsets to a high-altitude platform at roughly 20,000 meters over Kenya, a public rehearsal for commercial service in Japan. Meanwhile, the German Aerospace Center has matured OSIRIS laser terminals with compact optics and alignment units to 10 gigabits per second. Plenty to move live video and radar change decks between HAPS nodes and down to ground stations under clear skies. The architecture is obvious. Keep the fat pipe above the weather in light, narrow laser beams, talk to phones and patrol radios below with in-band cellular. The standards now recognize that reality. The International Telecommunication Union's World Radio Communication Conference in 2023 adopted resolutions explicitly aligning high-altitude platform station as International Mobile Telecommunications Base Station Operations, HIBS in the jargon, with terrestrial mobile bands between 694 and 960 MHz and again between 2500 and 2690 MHz. That cleared a regulatory lane for real services, not demos. Eyes drive the kill chain, so be specific about what you can see and how fast. Airbus's Strat Observer package, designed to fly on Zephyr and on maneuverable balloons, advertises live video and stills at ground sample distances down to 18 centimeters, with daily coverage on the order of 2,500 square kilometers and a steerable footprint that can reach any point in a box roughly 40 kilometers by 30 kilometers. That is not a cinematic flourish, it is a daily surveillance budget written in pixels and minutes. It allows a persistent platform to hold a convoy through the day, grab live video at decision points, and hand a ship, a battery, or an aircraft a continuous target file without the gaps that make humans guess. The directed energy story belongs on the ground for now, and it is no longer a thought experiment. According to the Navy's testing summaries and follow-on reporting of the Director, Operational Test and Evaluation findings, destroyer USS Preble used its Helios laser to down an aerial target during fiscal year 2024 testing. A milestone confirmed in 2025 coverage by Navy-focused outlets and defense reporters. The older laser demonstrator on USS Portland burned a drone in 2020 and burned a surface target in 2021. The lesson for anything fragile at altitude is not panic, it is planning. In clear air and within slant range, a ship or shore battery with a tens of kilowatts laser can turn your envelope or your tendons into the weak link. The answer is not to armor the sky. It is to fly more platforms than the Defender can burn in the weather windows they get, and to keep the critical links, optical trunks and high-value payloads, off axes where known lasers live. The regulatory screws are tightening in sensible ways. After the 2023 overflights, Congress told the Federal Aviation Administration to stop accepting mystery balloon as a normal condition of flight. Section 361 of the 2024 Reauthorization Bill directs the agency to develop a standard for continuous tracking and identity for high-altitude balloons, altitude, location, and identity transmitted in a form controllers can actually use. The FAA's action memo spells that out in the clean, bureaucratic language of systems engineering. In practice, if you want to live in controlled air for weeks, you will carry a transponder-like system and you will be visible. That is not fatal to covert work, it is simply the tax you pay to be in someone's airspace without causing panic. The legal ceiling above all this is still unsettled. There is no internationally agreed boundary between sovereign airspace and outer space. The Kármán line is a useful convention at 100 kilometers but not binding law. That ambiguity has been tolerable for decades because national practice has kept most traffic either well below, in aircraft, or well above, in orbit. With routine persistence in the 18,000 to 25,000 meter band, that gap now matters. States will keep applying air law to balloons and HAPS by default, and bodies from the United Nations Office for Outer Space Affairs to academic forums keep acknowledging the same thing. There is no fixed legal line, only practice. If you drift across a border, expect to be treated as an aircraft. That should inform both your routes and your rhetoric. On the industrial side, the capillary that feeds every solar airframe is chemistry. The record Zephyr sortie that ended on April 28, 2025, after 67 days, 6 hours, and 52 minutes is instructive in two ways. First, it shows you can string multiple weather systems together and keep a HAPS alive for months, including handovers across flight information regions. Second, it spotlights where the margin comes from. Amprius, the silicon anode supplier, has been public about delivering silicon anode lithium cells at up to 450 watt-hours per kilogram with third-party validation of 500 watt-hours per kilogram. Those numbers are not a luxury, they are the difference between a sunrise bailout and a hard landing. The return to service cadence in 2025, record flight, control termination, then another flight for telecom tests in Kenya, marks a program crawling out of trial and into operations. Airships are crossing the credibility line too, and not just in glossy videos. NASA's Earth Science Technology Office wrote it down. In August 2024, a high-altitude, long-endurance interferometric synthetic aperture radar, say it once, in SAR, flew on a psi stratospheric airship for 24 hours of stratospheric tests at 55,000 feet. In October 2024, psi and NASA and the U.S. Geological Survey announced a cooperative effort to hunt methane, superemitters, and monitor hazards, exactly the dual use case that pays the bills while proving endurance and payload control. If you want to understand why an airship in the stratosphere matters for defense, think wide area change at human timescales and station keeping with real payload mass. The same platform that maps methane plumes over a basin can sit above a maritime choke point and carry a compact synthetic aperture radar, a thermal suite, and a relay, then hold for days. Balloons, blunt and cheap, are quietly writing the persistence chapter in ink. Aerostar's Thunderhead pushed a steerable balloon to 336 days aloft, an endurance record the company logged publicly in March 2025 after crossing the 200-day mark in 2024. That is not just materials science. It is navigation by altitude layers, envelope discipline, and autonomy that rides the winds instead of fighting them. The mission set that fits that endurance is plain, passive mapping, relay, and the kind of wide area, low update stare that forces the other side to move with a plan. Defenders are evolving too. Canada's over-the-horizon radar build in the Arctic, part of the North American air defense modernization, has moved from concept to sites, with the Department of National Defense naming the first transmit and receive locations in July 2025. The public milestones point to initial capability before decade's end. The stratosphere slots neatly into that architecture, stitching tracks on slow, small things that a sky-bouncing radar can cube but not hold. This is the hybrid mesh that matters: space, stratosphere, skywave, and shooters tied by optical trunks and cellular downlinks. or spoils any clean system diagram, so take the Ukrainian lesson seriously without overfitting them. Reporting through 2023 and 2024 documented mass use of decoy balloons with radar reflectors, balloon-borne jammers, and direction-finding rigs built to sniff drone operators, and low-cost bomber balloons carrying mortar rounds. None of that looks like aerospace, but all of it is physics and incentives. Decoys force expenditure. Jammers force diversity. The answer for the stratospheric layer is the same as at 500 meters. Cross-check with independent sensors, keep your fire control on the ground, and do not let a single silky video feed seduce you into thinking you know the whole story. Sustainment is the lever arm the quiet professionals care about most, and helium is the quietest risk in the room. The U.S. Geological Survey's 2025 Mineral Commodity Summaries notes a 4% uptick in global output and continued supply fragility as Cliffside's privatization saga drags out. IDTechX and others project that demand to 2035 nearly doubles, with semiconductors the villain you cannot fire because everything else you want to do, AI, quantum, lasers, rides on that same supply chain. Those two sentences translate into operational rules. Your balloon fleet must leak less, recover what you can, and plan procurement like fuel in a war zone. Your airship fleet must treat helium as a precious asset, not a consumable, and your solar airplanes must be able to carry heavier payloads when hydrogen, not helium, shows up in the budget. The numbers are not abstractions. They are the difference between a fleet and a stunt. The kill chain with a persistent layer in it is faster, calmer, and meaner. The HAPS sees, the airship confirms, the balloon relays, the shooter kills. That shooter can be a destroyer's laser if the weather and slant range cooperate, a ground battery's radar-fused missile when a cruise missile shows its wake, or a long-range air-to-air shot cued by a track you never would have had without the stare. What matters is custody, never losing the contact, and the courage to let the cheapest, most persistent thing do the finding so the expensive thing can do the breaking. If you need a motto to write above the console, it is this: persistence over performance, custody over speed. Glide paths matter because procurement takes years and physics takes longer. Between now and 2035, assume 3 concrete steps. First, commercial HIBS service goes live in at least one archipelago or mountain state, riding the 2023 spectrum decisions and the 2025 handset trials to real subscribers. Second, air defense networks treat the stratosphere as a domain, not a blind spot, filters updated, interceptors trained for odd closure rates, and specialized tactics for slow cold targets written down and exercised. Third, airships settle into methane mapping, maritime pickets, and border stare, paid for by civil budgets and contracted by defense when needed. Between 2035 and 2050, the backbone gets optical, 10 gigabits per second HAPS to HAPS is routine, and the batteries creep towards 600 to 700 watt-hours per kilogram, which turns bad week into bad month survivability. After 2050, cognition gets real, onboard models learn the diurnal wind stacks, power budgets planned across weather systems, and payloads that send summaries, not pixels. None of this requires an epiphany. It requires budgets that outlast fashions and operators who love boring dashboards. The last human edge to guard is judgment under pressure, and it shows up in the smallest choices. When a HAPS track crosses a border at 20,000 meters in a storm, the right answer is usually to widen your loiter box and live to stare another day. When a Balloonship's downlink goes noisy, the right answer is to drop to your backup optical trunk or go store and forward instead of screaming more watts into a jammed band. And when someone offers you a cheap kill with an expensive missile, the right answer is often to decline the exchange and wait for weather that makes a laser cheap. There is no romance in that kind of patience. There is only victory. Training turns patience into habit. Crews who treat the stratosphere like a radio network and a weather machine first, and an aircraft second, make fewer mistakes and land more missions. The best control rooms look less like cockpits and more like utility grid operations, shift logs that read like maintenance novels, daily energy forecasts pinned to the wall, a whiteboard showing the wind shear between 18,000 meters and 24,000 meters in 4 colors. The handover ritual is boring by design. Outgoing lead reads the energy ledger, the thermal ledger, the link health, and the geofence file. Incoming lead repeats it back, then asks what could go wrong in the next 6 hours. They call it the "so what" round. Clouds rolling in at 2 p.m. local. So what? We pre-call the packs at dawn, trim payload duty cycle by 15% in the first hour of shadow, and climb 800 meters at noon to steal a better wind lane. Ground microwave interference forecast in the 2500 to 2690 MHz band. So what? We ride the optical trunk for backhaul and keep cellular beams tight and low. None of this wins you applause. All of it keeps the platform alive when the day stops caring. Mission sets blossom once you accept that you own time. Maritime choke points are the friendliest. A fixed-wing high-altitude platform station can box a strait the size of a small state, stitch a mosaic every few minutes, and hand the human only the frames that changed. According to the U.S. Navy's public test reporting in 2024 and 2025, shipboard lasers and short-range missiles now live in the same kill web as persistent sensors. The difference is that a platform at 20,000 meters sees wakes and shadows ground radar's missing clutter, then feeds the destroyer a track that never breaks. The vessel that flips its automatic identification system off at dawn does not become invisible, it becomes interesting. When a patrol boat drifts within 200 meters of a cable landing site, the operator does not guess, they watch the shadow and the wake angle and call the shot. That is what custody buys you. Border work is less glamorous and more honest. According to Department of Homeland Security and Civil Disaster Response case studies published over the last decade, the hardest problem is not seeing something once, it is seeing everything enough times to know what is new. A balloon ship with a medium swath optical head and a passive radio mapping payload can paint the same valley or fence line every hour on the hour for a season. The pattern of heat and motion around a smuggler's trail shows up the way a leak shows up in a basement, slowly and then obviously. A fixed-wing platform adds threadbare cellular service after a hurricane when towers die, then toggles back to stare once the phones stop screaming. None of that is offensive warfare. All of it reduces uncertainty and theft. Urban surveillance feels like cheating until you look at the constraints. Cities throw mirrors and heat at cameras, hide emitters in glass canyons, and drown radios in self-inflicted noise. The only advantage you own from 20,000 meters is geometry and patience. According to European telecom demonstrations and International Telecommunication Union decisions in 2023, using a high-altitude platform as an international mobile telecommunications base station lets you speak the same language as a tower. That makes the trick possible: rotate a handful of narrow cellular beams to pry open a dead valley for emergency crews in the morning, then push the payload back to optical and record traffic flows and construction activity in the afternoon. The day is a piano. You choose which octave to play. Arctic and desert are where persistence stops being a cool demo and becomes an obvious purchase. Canada's public milestones for over-the-horizon radar in the north point to an initial capability by 2029, and that long-reach ear needs eyes that can sit in the cold, hold a coast, and stare at small, slow things that look like clutter to everyone else. Desert reinforces the same lesson from the opposite side. Heat sinks and thin air are gifts if your thermal management is honest. The platform that learns to be happy at minus 56.5 degrees Celsius in the stratosphere has the opposite problem near the ground: too much sun. You solve both with margin and humility. Cold lets you run batteries without cooking them. Heat forces you to spend what's on pack conditioning so the chemistry does not eat you. Sensors make the campaign, so linger on what is real instead of what is cinematic. Electro-optical telescopes with ground sample distances around 18 centimeters from the stratosphere are not fantasy, according to Airbus Technical Material and Trade coverage through 2025. Stratobserver-class payloads do exactly that, and do it live. That level of detail does not mean you can read a license plate. It means you can count the cinder blocks in a wall, classify vehicle types with confidence, and notice new earthworks at a range that lets you adjust your loiter before dusk. Thermal channels widen the day. Synthetic aperture radar at lighter weights, the interferometric packages that NASA's Earth Science Technology Office wrote about in 2024, turn ground deformation into a map that exposes tunneling and runway repair. Passive radio payloads, descended from Spectrum survey kits, build an emitter atlas without transmitting a syllable. None of these need to be sci-fi to be decisive. They need to be reliable and boring and cheap enough to fly in numbers. Communications becomes the most beautiful kind of redundancy. According to the German Aerospace Center's public presentations, compact optical terminals have hit 10 gigabits per second in the field. That is the backbone you hang above the weather, a light pipe between platforms and down to quiet ground stations. Meanwhile, carriers have proven the other half of the story with direct-to-handset trials under a Zephyr over Kenya in 2025. The architecture that falls out is simple enough to teach in one slide. Thick, quiet laser upstairs. Thin, familiar cellular downstairs. If a jammer screams in the mobile bands you use for the handset links, the only thing you lose is the last hop, your backbone is still clean. If a cloud deck smothers your optical link for an hour, you write SATCOM or spread spectrum on microwave until the hole opens again. You never bet your whole day on one link. Weapons live on someone else's hardpoints in this ecosystem, and that is by design. The platform that kills is the one most at risk, the platform that sees, feeds, and never stops talking is the one that wins for months. According to testing summaries released by the US Navy and confirmed by independent reporting, shipboard lasers have crossed the "we shot a real flying thing" threshold, and short-range interceptors keep getting better radar fuses and smarter seekers. The sensor that gives those shooters custody at long range is the force multiplier. The geometry from 20,000 meters exposes cruise missile wakes that a shoreline radar misses and shows the long shadow of a small boat behind a jetty that a patrol can only guess at. When the shooter is ready, the platform hands coordinates and updates and gets out of the way. When the shooter is not ready, the platform holds the track and refuses to blink. The countersuite is as old as warfare. Jam the downlink. Spoof the navigation. Throw a decoy balloon with a loud radar reflector and see who wastes a missile. According to open reporting from Ukraine in 2023 and 2024, all of those tactics are in circulation, and they work just enough to be worth the price. The way you beat them is the way you beat every low-cost nuisance: diversity and patience. Ride multiple links. Cross-queue multiple payloads. Treat every single source truth as a rumor until another sensor agrees. If a jammer burns a hole in your band, point an optical trunk around it. If a decoy soaks your attention, let your change detection stack make the call. A fake radar cross-section without a wake and without a heat plume is an ugly mask you do not fall for twice. Resilience is not a slogan, it is math you say out loud. If a fixed-wing platform draws 500 watts through the night for 10 hours, it spends 5 kilowatt-hours before dawn. If the packs ride at 500 watt-hours per kilogram, 10 kilograms buys you the night leg with a little grace, 20 kilograms buys you 2 bad days in a row. If a balloon ship leaks helium at 0.1% per day, a 200-day mission loses a fifth of its lift before sunset number 200 unless you designed in margin and recovery. According to the U.S. Geological Survey's 2025 mineral commodity summaries, global helium production rose year on year by single digits while demand pressure continues from semiconductors and other high-tech sectors. Independent analysts project demand nearly doubling by 2035. That is not a doom forecast, it is a reminder that gas losses are war losses when you fly for seasons. Valve discipline, better barrier films, and recovery plans are not clever. They are survival. Reconstitution is where the cheap platform becomes a weapon. According to Aerostar's public logs, steerable superpressure balloons now live aloft for hundreds of days, and the launch cadence has become routine. A unit that can inflate, integrate, and release a dozen balloon ships before lunch, and recover a couple after sundown for payload swaps, wins campaign tempo without needing a single magic technology. Airships will never be that quick to turn, but they amortize their slowness with payload mass and station keeping that laughs at the wind. Fixed-wing solar aircraft sit in between, the quiet workhorses that make everything else better by knitting them mesh together. Industry is where the glide path turns from marketing slides into fleets. Alto has real government and telecom money behind it. In June 2024, NTT Docomo and Space Compass committed $100 million into AALTO to mature service. And in early 2025, ALTO, Space Compass, and partners were already showing connectivity tests over Kenya with commercial devices. BAE's Faza 35 matured a stratospheric flight profile with back-to-back turnarounds and is standing up. A Block 20 airframe for multi-day operations. Skydweller, a solar aircraft built on the bones of the manned Solar Impulse, ran multi-day unmanned flights with Naval Air Systems Command this July. And the UAE-based Myra Aerospace ran a fifth-generation phone call over a Rwandan test from a fixed-wing HAPS at nearly 17 kilometers back in 2023 and is now flying new airframes in the Middle East. This is not one program. It is an industrial niche with multiple players now clearing the last reliability gates. Speculative. Night, 900 kilometers off Hokkaido, September 2031. A weather front has scrubbed polar orbit imaging for 18 hours. The over-the-horizon radar has a massive slow targets in the Sea of Okhotsk that could be anything from fishing gear to a spread of conventional sea mines thrown into the surface drift. 2 Zephyr-class aircraft are already up, battery margins green. The operator pushes the box 20 kilometers east to get an angle off the weather and opens the high-resolution head. The feed tightens to a single wake line, a 6-meter uncrewed boat with a shallow draft and a steel bulb welded into the bow. The second Zephyr goes to thermal and spots a barely above sea level heat smear 10 kilometers behind the lead, a slave boat riding with its engine in deep throttle modulation to confuse acoustic classifiers. The human on the loop marks the tracks and hands them to a destroyer whose laser is up between squalls. The first volley is a dazzler to burn the slave's electro-optics, the second is high energy at short range, pinning the lead's electronics long enough to drop a low-cost guided round right into its engine bay. The destroyer's helicopter never leaves the deck. The mission is a pairing, persistent eyes that do not tire and a shooter that does not waste million-dollar interceptors on holes worth 5 figures. The weather turns again. The balloon ship you did not notice in the vignette is 50 kilometers south, feeding the whole exchange to shore through an optical downlink and caching the take on board for a quiet dump later. End speculative. You do not get this for free. Jamming can blind a balloon ship if its autonomy stack assumes truth in the downlink. Spoofing can paint a ghost convoy that burns analyst hours. Weather can still put a fist through a wing or an airship envelope. The counter to jamming and spoofing is diversity and physics, optical links that ignore radio noise, inertial and stellar navigation that roll on when GNSS is dirty, cross-checks against independent sensors. The counter to weather is margin and prudence, power reserves that do not gamble on perfect sun, envelopes and tendons that were tested to the edge. There is no silver bullet, but there are enough lead bullets that the magazine does not run dry. The near future is clearer than most technologies give you. By 2035, expect 3 patterns to be normal. First, fixed-wing HAPS in fleet operations, launching from a handful of certified HAP sports in favorable latitudes and staging to where they are needed with handovers mid-air, informed by wind models and real-time radiosonde. Second, stratospheric airships regularly holding station for week-plus missions over choke points and disaster zones, ferrying heavier payloads. Synthetic aperture radar, wide-area hyperspectral, that once required a satellite. Third, mobile networks that treat HAPS as just another sector in the radio access network, thanks to the HIBS framework that lets a stratospheric base station speak the same language as a tower. We can point to programs, not wish lists. Between 2035 and 2050, the muscle moves to scale and survivability. Optical inter-HAPS links at 10 gigabits per second and higher harden the backbone and cut the dependence on spectrum and ground relays. Large format silicon anode or lithium metal chemistries at 600 to 700 watt-hours per kilogram stretch night legs such that, bad weather weeks, become tolerable. Carbon films, better barrier layers, and smarter valve packs start treating helium like gold, not water. The operational pattern is less, 1 big balloon over 1 city, and more, a cell of 4 platforms, 2 wings, 1 airship, 1 spare, cross-queuing and replacing each other as they tire. By mid-century, air defense will have integrated lasers as weather-dependent point defenses and high-power microwave as short-shot area denial for drone swarms. The stratospheric mesh will act as the spotting and fire control layer for both. From 2050 to 2075 and beyond, the lever is cognition, onboard models that learn the wind structure in real time and plan energy budgets across days, not hours, and payloads that make sense of what they see without shipping every pixel to the ground. It is also law. Routine cross-border persistence will force explicit sovereignty rules for the stratosphere the way the Chicago Convention settled aviation rules a century ago. Expect global frequency plans for stratospheric cells and widely published keep-out volumes over the most sensitive sites, with escalation dynamics that are publicly understood rather than privately guessed. And if you stretch to 2125, be bold but keep your feet on concrete. Humans will still have satellites, they do different work, but the stratosphere will be where the dailiness of security happens. The century-long trend is not toward one giant platform that never lands. It is toward many small ones that are cheap enough to lose and smart enough to share work. Picture swap body payloads that click into a common electrical and thermal bus on a balloon ship or solar airframe, flown by operators who think like network engineers, not pilots. Picture over-the-horizon radar queuing a half-dozen eyes that hold a contact while a ground laser and a short-range missile team decide who pays what to kill it. Picture an oil basin where methane leaks do not hide for months because a helium airship wandered across each pad every other day. None of that requires a new law of physics. It requires margin, maintenance, and decision rights that keep people where they add value, choosing, not chasing. So let's get concrete about the airframe guts. because the devil that keeps you aloft for months lives in thin film, tendons, and heat budgets. The modern superpressure balloon, the workhorse of long-duration, balloonship, constellations, is a pumpkin, many gauze of ultra-thin polyethylene, each constrained by high-strength tendons that carry load so the film can be astonishingly thin, on the order of 38 micrometers. That architecture is what lets a balloon hold constant volume and near constant altitude through the day-night cycle instead of yo-yoing with every sunrise. NASA's own analyses describe superpressure pumpkins fabricated from roughly 38 micrometer films with aramid or polybenzoxazole tendons running base to apex, still thin as a shopping bag, but structured like a tensegrity shell that keeps its shape at float. If you want a number in your head for conditions up there, set your mental cockpit to minus 56.5 degrees Celsius and leave the thermostat alone. That is the international standard atmosphere temperature plateau from about 11 kilometers to roughly 20 kilometers. Air gets thin, cold, and docile compared to the messy troposphere below. Density falls to a fraction of sea level, which is why a solar airplane with a glider's wing loading and 2 lawnmower-class propulsors can cruise where jets wheeze. The environment matters because every watt of waste heat and every gram of battery becomes both a life support system and a liability. Payloads live or die on power and link closure. The optical backhaul story has matured fast. Germany's aerospace lab has been flying OSIRIS laser terminals that now quote up to 10 gigabits per second in compact packages, with pointing units that play nice with high-altitude platforms. Airbus's Netherlands team presented HAPS LaserCon terminal results in 2023 specifically to interconnect Zephyrs and satellites. That is your stratospheric backbone, free space optics above the weather and above most spectrum politics, with radio downlinks to device underneath. It is not magic. It is link budget and jitter control bolted to an aircraft that does not come down. The radio layer is the other half. Regulators have now blessed the idea of a base station in the stratosphere. The International Telecommunication Union's Resolution 218 sets the table for HAPS as International Mobile Telecommunications Base Stations, HIBS in the jargon, operating in the same bands as terrestrial macrosites. Asia-Pacific regulators openly talk about commercial HIBS as early as 2025 for coverage gaps. That is why Deutsche Telekom and stratospheric platforms were demonstrating live LTE and then 5G from an airborne mast as far back as 2020, and why you see serious carriers, NTT Docomo and Space Compass, writing checks and flying handsets on a Zephyr over Kenya in 2025. This is not PowerPoint connectivity anymore, it is in-band, call your phone radio from 20 kilometers. On the fixed-wing side, your energy math is brutal but workable. Airbus's Alto lost one Zephyr after 64 days in 2022, but in 2025 the team pushed to 67 days, 6 hours, and 52 minutes before ditching the airframe in a designated sanctuary in the Indian Ocean. That is not a marketing claim. AALTO, Aviation Week, and Flight Global all published the specifics, and Amprius bragged about its cells powering the record. Battery energy density helps, but the real art is in control laws that survive the intertropical convergence zone and keep the aircraft in the cold when the cold is free refrigeration for your packs. Solar HAPS are no longer a one-horse show. BAE's Faza 35 reached the stratosphere in 2023 and 2024 and, by BAE's account and independent trade coverage, now turns sorties that launch, float, land, and relaunch within days, with a Block 20 airframe designed for multi-day endurance on 10 to 15 kilogram payloads. The difference between, we touched the stratosphere, and, we can loiter there through a full diurnal cycle with usable payload, is everything. Faza is crossing that line in public flight notes. Meanwhile the US Navy and Skydweller just proved what many suspected, a solar mothership with wing loading and storage margin can stay up long enough to be operationally boring. 73 hours in a single non-stop test, 3 days of continuous ISR without a drop of fuel. Boring is victory. Persistence is a tactic generator. Airships are the third pillar, and their advocates are finally delivering credible day-night cycles at altitude. SAI's New Mexico tests in August 2024 kept a stratospheric airship on station for a full diurnal cycle, solar by day, batteries by night, then recovered under control. NASA's Earth Science Technology Office reported a 55,000-foot synthetic aperture radar, high-altitude, long-endurance in SAR, flying on that platform. The company then turned around and announced a partnership with NASA and the U.S. Geological Survey to target methane, super-emitters, and wildfire signatures. If you want a mental model, picture an omnipresent methane inspector and fire lookout that can also carry a small SAR and stare. The whole fabric chemistry is proprietary, but independent trackers have logged vehicle IDs, altitudes, and the 24-plus-hour time aloft. None of this changes the physics of the balloon. Superpressure buys you altitude stability, tendons carry stress, and film thickness is the difference between a year and a week. The literature is explicit about how small changes in gore geometry and deployment pressures translate to seam loads you cannot see until a wrinkle turns into a catastrophic lobe inversion. The good news is that the engineering is mature. The better news is that the endurance is now strategic. Raven Aerostar's Thunderhead series crossed 200 days aloft in 2024 and then 336 days in 2025 on a controllable platform, close to a calendar year of persistent presence, backed by a steady cadence of launches across exercises from Guam to Norway. That is not a boutique stunt, that is an industrial tempo. There is a reason national airspace rules are catching up. The United States baked high-altitude balloon tracking into the 2024 Federal Aviation Administration Reauthorization, Section 361, after the country discovered on live television that unknown lighter-than aircraft can drift 1,000 miles before you get your intercept geometry right. The FAA's action memo lays out the bones of a standard, altitude, location, identity, continuously transmitted in a way controllers can use. The practical outcome is transponder-like visibility for anything that wants to live in controlled air for weeks. Be seen or be swatted is an oversimplification, but not by much. The telecoms world is not waiting for the last page of the rulebook. Stratospheric platforms, with Deutsche Telekom and other partners, demonstrated integrated LTE and then 5G from the sky years ago and have been iterating phased arrays that throw hundreds of steerable beams from one airborne panel. Meanwhile, real carrier trials are going direct to handsets. In March 2025, Space Compass and NTT Docomo ran live data sessions to 4G phones under Zephyr at about 20 kilometers over Laikipia County, Kenya. As part of a commercial path toward HAPS rollouts in Japan, the same consortium invested $100 million in AALTO in 2024. Activity follows incentives. WRC 23 opened a regulatory lane, and carriers stepped into it. Put these pieces together and the control loop you actually fly in war is short and boring. A balloonship constellation sets a 500-kilometer radio horizon from 20 kilometers altitude. That line of sight buys you two things that matter: direct links to small radios on the ground and guaranteed line of sight to your airborne laser or microwave backhaul. From there, your kill chain is just routing. Stair payloads cue movers, movers cue shooters, a human adjudicates the weird cases. The human remains the arbiter of ambiguity, child with a goat versus scout with a radio, and you design the autonomy so that the only loops that close on their own are the ones that are safe to be wrong about. That is how you keep human on the loop, honest without turning every engagement into a committee meeting. Where does the physics bite back? Batteries, always. You must by the night. An 8-hour winter night at mid-latitudes with minus 56.5 degrees Celsius ambient is a worst-case pack scenario. Silicon anode cells stretch that curve, as Alto's supplier was happy to say after the record flight, but you will still claw for every watt in avionics, heater control, and payload duty cycle. Even small thermal mismanagement, warming packs to improve discharge at the cost of parasitic draw, cascades over weeks. This is why flight controllers talk about energy neutrality with religious intensity. The airframe lives or dies on whether the sunrise before you run out of battery arrives with enough irradiance to arrest the descent. Industry is converging on a split ecosystem by 2035. Fixed-wing solar for wide area, moderate power payloads and smart backhaul. Airships for heavier payloads and geostationary-ish station keeping. Steerable superpressure balloons for cheap persistence, especially when you need dozens aloft to keep a target set under unblinking watch. On the ground, 2035 looks like this: over the horizon radars in the Arctic, with initial operating capability targeted for 2029 in Canada, push queuing deep into the north, and stratospheric platforms fill the coverage holes inland and at sea while feeding ABMS-style fusion cells. Bring your own shorthand, but the picture is the same: deep queuing, persistent eyes, short shooters. The economics are ugly where helium is concerned. The U.S. Geological Survey's 2025 summary flagged a 4% uptick in global output and continued supply fragility as Cliffside's privatization saga drags out. IDTechX and others project that demand to 2035 nearly doubles, with semiconductors the villain you cannot fire because everything else you want to do, AI, quantum, lasers, rides on that same supply chain. Translation: your balloon fleet has to get stingier with helium or leak less of it, otherwise you are building operational risk into your gas budget. This is exactly why you see so much interest in airships that launch with helium but never vent, and balloons with better film gas tightness and valve discipline. Reliability is now an operational variable, not a press release. Zephyr's 2022 loss after 64 days was a useful public lesson in high-altitude turbulence and the perverse risks of descending through weather after months above it. The point is not that fixed-wing HAPS are fragile, the point is that you design your aborts with the same care as your crews, sanctuary splash zones, energy margins to wave off, and a telemetry stack that tells you days in advance that your packs are decaying or your film is creeping. The Royal Aeronautical Society's post-loss write-ups and engineering press coverage were candid on this. Fixing the control laws and energy margins is the whole reason 2025 looked different. Weapons and counters keep each other honest. Lasers at sea are maturing, with the US Navy's Helios on USS Preble burning an aerial target in fiscal 2024 and the older Portland laser demonstrator disabling a drone in 2020 and torching a surface target in 2021. That matters because once you can reliably put tens of kilowatts on a fragile wing or a balloon's tendon field, your cost curve for kills bends toward the ship with the generator. But it cuts both ways. The Balloonship constellation that costs you tens of thousands per node can trade attrition with $1 million interceptor all day and still win on exchange ratio. The practical answer is redundancy and maneuver. Platforms move. Constellations cross-cover. And anything that cannot maneuver carries decoys and a Grim Reaper app that tells operators to terminate before a capture. Balloon warfare has already gone low-rent and lethal in Ukraine. Public reporting documented helium balloon, bomber, drones dropping mortar rounds guided by cheap autopilots, and both sides have used balloons as decoys and as radio relays to stretch the range of ground drones. It is a reminder that in the stratosphere you buy exquisite persistence, but in the layer cake below it physics is cheap. A bag of gas, a GPS, and gravity will ruin someone's day if you do not control your airspace. The difference at 20 kilometers is governance, the difference at 2 kilometers is whether you can see and jam. If you are building the ops center around all this by 2035, your dashboard is simple. Energy state for each platform. Link health, optical backhaul and downlink spectrum occupancy. Weather field above and below. A geofence library tied to rules of engagement and airspace authorities. An array of promote to shooter buttons that the human can touch only after an AI stack has done the rote work, correlating synthetic aperture radar change detection with electro-optical tracks, checking electronic emissions against known order of battle, and marking everything that smells like a decoy. People watch the edge cases, not the clutter. By 2050, you assume lasers, high-power microwaves, and rail-fin interceptors are all part of the air defense web. The best platforms, solar fixed-wing for wide-body persistence, airships for payload, balloons for numbers, carry their own soft kill, dazzlers, interference shaping on the downlink, and spoofer-aware positioning that makes a jammer burn itself alive. You also assume that recovery and reconstitution are routine. Aerostar's cadence hints at it already. The day you can launch a dozen steerable balloons before lunch and recover 2 that evening to swap payloads, you have turned persistence into a logistics drill rather than a hero project. And yes, the maps change when you stitch all of this into continental defense. Canada's Arctic over the horizon radar grid, the 4 sites, 2 transmit and 2 receive, targeted for initial capability by 2029, extends the warning line, HAPS fill the view gaps, soak the Arctic shipping lanes, and provide jamming resilient relay paths that do not depend on a single satellite bus. Once you can drape laser and microwave trunks from HAPS to ground fiber, your everywhere radio becomes a thing, even where towers make no sense. That is what persistent air presence actually buys you, a geography-agnostic network and a stare that does not blink when the weather turns ugly. We should not be romantic about sustainment. Helium stays tight only if your films and valves are good, batteries live long only if your thermal control is better than your pride, and solar aircraft only work if your operational latitudes and seasons are matched to their power budget. But the trend lines are clear. Optical backhaul at 10 gigabits per second is not exotic. A single HAPS payload can collect 18-centimeter imagery over thousands of square kilometers per day, with steerability that turns revisit into you have live video now. And carriers are placing their bets, not just with press releases but with flight tests to handsets and 8-figure equity checks. The stratosphere has finally become a layer we can occupy, not just cross. Now imagine the human side, because the friction sits there. You train operators who think like network engineers as much as pilots. You write your standard operating procedures to assume you will be blamed for anything that drifts, and you log every second of telemetry so that when a national aviation authority calls, you can produce altitude, location, and identity without breaking stride. And you keep repeating the same principle until it is muscle memory. People choose. Machines chase. The platform's job is not to be clever. It is to be present, to be cheap enough to be fearless, and to hand a human a clean, timely choice. Which is why the next edge to sharpen is signature management. The lie you tell the sky is simple: be boring. A balloon ship is a cold sack at ambient, reflective film turned to the sun, payloads buried behind low scatter windows, emissions pruned to whisper salvos. A fixed-wing HAPS keeps its props slow and its fuselage smooth, then lets geometry do the rest. From the ground, slant range and a sparse thermal plume beat most short-range infrared trackers. From the air, a fighter's radar sees only a small, slow cross-section that moves like weather. The counters are obvious and already in motion. According to Reuters reporting the week after the 2023 Chinese balloon shoot-down, North American Aerospace Defense Command retuned its filters to stop discarding slow movers and opened the gates, which is the radar operator's way of saying, we chose to see the clutter and sort it in software. That is the correct response in a world where persistence at altitude matters as much as speed at low level. Cost exchange is the next uncomfortable truth. If you force a defender to shoot a $1 million class interceptor at a sack of helium and plastic that cost a rounding error, you do not need exquisite effects to win the ledger. The Missile Defense Advocacy Alliance's running totals put an AIM-9X Sidewinder near the $1 million mark in National Advanced Surface-to-Air Missile System use. Contemporary reporting on the Air Force's AMRAAM buys puts those missiles in the million-plus tier as well. The point is not the exact invoice. It is the shape of the curve. The platform that soaks attention and draws expensive fire has already done violence to a defender's magazine depth and budget line, and the second-order effects, tankers, alert fighters, radar hours, compound the pain. According to the connected sources and updated data as of late 2025, the palette is already on the table: stratospheric wings that fly for months, balloon ships that live for seasons, airships that hold station through a night, lasers that kill when the weather is kind, radars that see beyond the curve of the Earth, and battery chemistries that reward patience with endurance. The lesson is not hidden. Persistence wins. Custody wins. Cheap wins. The sky will still have jets in it. It will also have platforms that never hurry and never sleep, and they will shape the hours in which the fast things matter.